Hey, course 1, lesson 110 talks about getting symmetrical. What symmetry looks like might be helpful to have an actual textbook or something you can turn around and manipulate to look at different pictures in different orientations, as well as maybe a piece of paper you cut out, a shape like a square and maybe a equilateral triangle to practice folding, or draw some of these shapes so you can write on them your lines of symmetry. This could be helpful to have along with you as you view the lesson. A line symmetry means it can be divided in half so that both sides are a mirror image, like that picture at the bottom, like a butterfly or some fish. A lot of types of leaves, they can be folded to match up perfectly. Generally, things that are manufactured, you want to make them look that way too. It could be just a kitchen sink, or looking at a car from the front. They have symmetry because it looks better when it does. Two-dimensional figures, like a triangle, can also be symmetrical. A two-dimensional figure is symmetrical if a line can divide it into mirror images. The line here they have labeled R divides it into two smaller triangles, right? So this bluish line is called the line of symmetry, right here. And as a result of it, we see it split into two smaller triangles. We've got this one and its mirror image. It needs to look exactly the same, which it does. This one right here. Okay, and because of the line there, we see images that really are the same. Okay. You might be asked, how many lines of symmetry in a shape? Well, a rectangle is kind of fun because it's got more than one here for us. It's got this one that if I fold it over, maybe you have a piece of paper that you cut into a pretty good rectangle. You could fold it, like we say, hamburger style, or you could fold it this way, hot dog style, and again, it should match up. 2 lines of symmetry is it. Nothing else would work on that. Example 2, which one is not symmetrical? This one has equal sides, so really actually you can cut it these 3 ways, which is fun to remember. You can go diagonally too. This one has 2 equal sides, which means we're going to be able to cut it so that those match up this way. So I could fold it like that. You could practice with a triangle where this and this side are, those equal sides are the same, but then that hypotenuse is a little longer. You can still cut it one way, maybe not 3 ways, but one way. If you actually grabbed a ruler and took it to your book, you'd see that these are 3 different sides. What kind of triangle is that? We call that a scalene triangle. And if it's scalene, no sides are the same. That means there's no way you're going to be able to fold this. None of them are going to work. So C is our answer. Kind of helps when they tell us one of them isn't, so we don't have to second guess ourselves. We know one of them isn't. That one clearly the least likely. Rotational, you see the word rotate in there. Symmetry, it means we're going to be able to turn an image less than all the way around, and it reappears as the exact same image. If you look at like example 3, which of these has rotational symmetry? If I turn A, it's kind of like this shape I have right here. I guess I do that. I think that looks more like the shape. Yep. So we got a rectangle, and I can rotate that rectangle 90 degrees. Okay, definitely still different, but now 180, it looks, another 90 makes 180. It looks exactly the same, even though I haven't gone all the way around yet. If I did go all the way around, every shape would look exactly the same, but if it doesn't need that, it only needs to go, say, 180 or 270, then it is rotational. The same is going to be the case for B. You can rotate this about 180 degrees, I think, and you're going to go back to this shape. It's going to be upside down, but it looks the same. You don't realize it's upside down. But this one, if you turn it halfway, you're going to end up with the long edge on the top. That's at 180 degrees. Of course, this is going to be 270, so you need to go all the way around to make it the same. So doesn't have rotational symmetry, and neither does letter D. Can you see that? If I turn letter D once, I think you get like that, right? And then if you turn it another way, it's going to be the opposite. It's going to be backwards. Goodness. Well, it's going to be backwards. Anyway, I got to fix something on my pen, but you get the idea. Why don't you do the practice here? The letters are real fun. You do A, B, and C, please.